Hi all, morning. The topic that which we are going to discuss today is on the virtualization. When we start learning about cloud computing, it's essential to learn about the virtualization because virtualization is highly used in the cloud computing. So let's try to understand the basic concepts of virtualization. I will try to explain the cloud computing in much simpler terms as much as possible without jargons. I will try to explain with some relatable examples as well. Yeah, let's go ahead. So, what is virtualization? Virtualization is actually the process of converting one physical machine into multiple virtual machines. So first let's start from the physical machine. So you need to understand the structure of a physical machine in order to understand the virtual machines then. So let's touch base the physical machine structure first. So I have actually given the numbers for diagrams as well. So we'll start with the diagram 1. So the diagram 1 gives the basic computer structure. If you look into a computer, it contains CPU and monitor. So monitor is mainly used for displaying the user interface to the users, whereas all the CPUs actually it's like a heart of the computer. So if you take any CPU though it has many peripheral devices, CPU contains two key components, that's RAM and ROM. So these are the things which we are going to discuss right now. So we can actually ignore the monitor part. You can even operate a CPU without a monitor. You don't need a monitor for all the computers. For example, if you look into the data centers are like it's a bunch of CPUs connected in a network where you don't have monitor for each and every CPU. You don't have that. So let's ignore the monitor part and let's focus more on the CPU. Now let's move on to the diagram 2. So if you look into CPU, though we have, as I have mentioned, though we have plenty of peripheral devices, let's focus on RAM and ROM. RAM is type of cache memory. So its memory gets wiped off when you turn off the computer, whereas ROM memory is not that case. ROM memory continues to hold the data even if the computer is turned off. So you need to understand the main difference between RAM and ROM. I know I'm teaching all the old school concepts, but it's necessary to know all these concepts here before moving into virtualization. Fine. So we have two peripheral devices. As I have mentioned, RAM memory is type of a cache memory. So we always opt to install all the applications in the ROM memory. So install any softwares are installed in ROM memory and not the RAM memory. So what is the base software? So base software is operating system. Your operating system is the base software which leverages the communication between hardware and application software. So let's see, let's move step forward and let's see what it actually means. When you turn on a computer, the first set of program that runs, the bootstrap program that runs actually comes as part of the operating system. So when you turn on the computer, so it gets the power and it starts executing that initial program which loads your complete, okay, it boots the complete machine right from the scratch. So that boots, so OS is the base program that gets executed when you load when you start a computer. So you can't and when you turn on the machine, so that actually leverages the communication between the hardware and the other application software. So when you turn on the machine, the first program that you see in your screen is the OS, operating system, be it Windows or be it Linux, any OS, but the first program that gets loaded is operating system. And once you get your operating system loaded, then you will be able to see all the other applications like your browser, Google Chrome browser, Adobe Photoshop, Adobe Lightroom. So all those are application softwares, but the base software is operating system. So that's how the sequence is. So you do have a hard disk hardware, and then on top of that you do have a operating system, and on top of operating system you'll be able to see all the application softwares. So and when the machine gets turned on, these softwares get so these applications gets loaded to the RAM memory, and they are used by the RAM. Fine. Now so I hope you now understand about the main structure of the CPU. Now this is common in all the machines, so be it your desktop, be it your laptop, whichever machine you own, uh, it's it's actually the same for all the machines. So I do own a personal laptop. Again, I that laptop has a hard disk. I have an SSD hard disk. That's the ROM memory, and then I do have a 8 gig RAM. That's the RAM memory. Okay, we do have processor. I'm not speaking about the processor here right now. So let's keep it to basic level. Okay, we are not discussing about the processors in this video. Now if we move on to the third diagram, now so that's where I have shown you how it works. Operating system, that's called as a system software, and then other applications like Apache, Java, Google Chrome browser. So all those are applications. Okay, they're actually the application software. Now assume you do have a physical machine, 8 gig RAM, and then 512 gig hard disk with a Windows OS. Okay, it can be Windows or Linux, anything. Now let's move a step towards the virtualization. So what is a virtualization? It is the mode where you enable your one physical machine to act like multiple independent machine. So as I have mentioned, each independent machine has its own CPU, its own RAM memory. So enabling that type of multiple individual virtual machines in a one physical machine is virtualization. So let's see how it works. In the diagram, if you start from the bottom, we do have a hardware. So that's where actually your hard disk is, and then as I have mentioned, the hard disk will be containing the operating system. Now here comes a layer called hypervisor. This hypervisor this hypervisor it is mainly used to enable your hardware to hold multiple operating system. So this is where it will actually partition the hard disk. Okay, it will kind of partition the memory. It will split the memory, and it will give one amount of memory for Windows OS, and one amount of memory will be given for Linux OS. So by this way, you can run two machines in one single physical machine. I mean, you can run both Windows and Linux in one single physical machine. So in order to avoid the confusion, in this example I have taken two Linux machines from one single hardware. So so here I have shown a picture where we have two virtual machines, VM1 and VM2, and both of them has Linux operating system. So and the RAM has been split into 4 gig for each of them. So this is okay. This is how this hypervisor will enable you to run multiple copies of operating system on top of a single hardware. So assume, okay, when you look into large enterprises, they used to purchase and data centers. Okay, if you look into large enterprises and data centers, they do have a huge amount of memory space, like 64 gig or more than that. 64 gig RAM or more than that, and that will be partitioned into multiple VMs. See, for example, let's say you have a web application. Your web application may not be using a RAM memory more than 8 gig. Installing one web application in a RAM memory more than 8 gig, okay, installing one web application uh, which needs 8, okay, its requirement is 8 gig, whereas what you have is 64 gig. So when you install that and when you run that, you actually underutilize that hardware. So in this case, you can build 8 VMs. You can build 8 VMs out of this 64 gig memory, and then you can run 8 virtual machines, 8 individual machines out of one single physical hard disk or hardware. Okay, so actually I have tried this in my personal device as well. So I made use of this VMware. Okay, we'll cover that after some time. Let's look into the uses of virtualization. So it helps you to effectively utilize your hardware. So yes, as I have mentioned, assume you do have 64 gig RAM, and if your application is in need of just 4 gigs, running 4 gig application in a 64 gig RAM is it's purely a crime. Okay, you can't do that. You can't underutilize the hardware. So in that case, actually you can build 16 VMs out of this, and you can run 16 machines from one single hardware, and all of them behave like independent entities unless you do have a hardware failure. Any failure in one VM will not impact the failure to other VM. So okay, in my project we do have a big data center where we do run large number of VMs. If any application running in VM1 goes out of memory, or if there is a GC error, that will not impact the application in VM2, because VM2 has its own memory, its own dedicated memory, its own dedicated CPU. So VM2 is not impacted by any performance degradation of VM1. So that's the key. That's another key that actually reduces outage for all the applications. In that removes the single point of failure. So that's another key benefit of virtualization. So I hope you would have understood this. So having one single hardware, and then you have hypervisor on top of that. This hypervisor will enable you to run multiple operating system on top of your single hardware. Okay, so hypervisor actually enables the virtualization and helps you to run two set of OS. So it can be Windows, Linux, or Linux. It can be Windows Server also. It can be anything, but this is how the virtualization is achieved. And then so I have used VMware to enable the to use the virtual machine in my PC. So in case if you are a Windows user, you can see this enable virtualization option in the BIOS. So when you boot your machine, go to the BIOS control. There you will be able to see the enable virtualization option. So enable the virtualization option, and then you can actually run a Linux image even within a you can I think I ran a Ubuntu or CentOS. I couldn't remember that. I ran a CentOS image within Windows machine. So I have a Windows machine actually in the background. Within that, I do have a separate window where I will be running the CentOS. That's a completely different Linux OS. Okay, so that's how I was using virtualization in my project. So that's it for the day. Please like and leave your comments. Let's try to learn more concepts in the future. Thank you. Have a good day.